So what can we do about Alzheimer's? There are non-prescription remedies, and I think we should talk about those first. They don't cost nearly as much. They're not very good, but there are some things you can do. You can take vitamin E. You can take ginkgo biloba. Both of those, I congratulate their manufacturers. They didn't have to do it, but they spent a lot of money running rigorous clinical trials. And those clinical trials showed that vitamin E, and they also showed that ginkgo were significantly beneficial to Alzheimer's patients. Okay, sounds good, doesn't it? You have to watch scientists, however, when they use the word significant, because they probably mean something that you don't. Okay? You think I just said they had a huge benefit. I didn't. I said they had a consistent benefit. Significant to a scientist means consistent. So there was a consistent, tiny little significant effect. The spouse couldn't see it. The family couldn't see any beneficial effect. But if you do really sensitive memory tests, yes, you could see an effect. These things won't hurt you if you take them in reasonable, modest doses. And if you want to do that, I think that's just fine. As we talked about, get your cholesterol down. Anything that you do for your heart will be good for your brain, and I think it could help you ward off Alzheimer's disease. So that includes exercise. Be mentally active. It will enrich your life, even if it doesn't protect you from Alzheimer's disease. And then last is ballroom dancing. Now, you might think that's funny, but actually there was a study 5 years ago, one of the best studies. It was done by Albert Einstein College of Medicine. And they went and surveyed something like 5,000 elderly people in retirement homes around New York City. And what they found, you know, they thought it was going to be something like swimming or running or walking or playing bridge or something like that. They had all these questions. Do you do this? Do you do that? Do you do that? You know the one that won? Ballroom dancing. Okay? I signed up for Fred Astaire. I'm not kidding you. 8 months later after I saw this. It improved my dancing. I don't know what it did for my brain, but I enjoyed it, actually. So take up ballroom dancing. It may help you. And your wife will like you better because you're not as clumsy as you used to be on the dance floor. For prescriptions, there are 2 FDA-approved medications for Alzheimer's disease, and they're both worth considering. The first of them is a drug called Aricept. It is a drug that evolved from another drug called CORTEX, which was developed by Dr. Walter Moose, who's my boss here at SRI. He's head of biosciences. So CORTEX was developed and it sort of morphed into Aricept, and it was the first drug that was ever FDA approved for Alzheimer's disease. And trust me, the FDA does not approve things lightly. Okay? So it went through very rigorous trials. Here's how Aricept works. About 30 years ago, maybe 35, I'm really showing my age now, Dr. Peter Davies at Albert Einstein discovered that a particular chemical messenger molecule in the brain called acetylcholine is grossly deficient in Alzheimer's disease. It's almost wiped out. And so he published this, and the more astute people like Dr. Moose said, well, you know, if we could somehow boost the amount of acetylcholine that's left in the brain, we could do some good. So acetylcholine is a chemical messenger molecule. It's a molecule that nerve cells use to talk to each other. And it is by communicating via these neurotransmitters that your nervous system works. So thinking the simplest thought, wiggling my finger, that's millions of nerve cells all working together, and they talk to each other and work together by virtue of these chemical messenger molecules like acetylcholine. Deficiencies of acetylcholine were known at the time to be somehow involved in memory, and so it made some sense. And so Walter and his colleagues at Park Davis developed this drug that boosts acetylcholine that's left in the brain, and it did have beneficial effect, and it was approved by the FDA. Now that said, let me also, and I think everyone should try it. That said, it has its limitations, and you should be aware of that. First one is, acetylcholine is not just a chemical messenger molecule for your brain. It's also used by nerve cells to control your heartbeat, your intestines, your bowels, your sweat glands. It's used all over your body. And when you take drugs like Aricept, you're boosting the acetylcholine not simply in your brain, but also throughout your body. And so, as you might expect, some patients experience nausea, diarrhea, vomiting, heart palpitations, midnight sweats. Okay? That is, I would still rather have all of those combined than Alzheimer's disease, so this is worth doing. Second thing to say is this is not a cure. Aricept addresses a cognitive symptom. It makes patients more attentive. It helps them remember better, but it doesn't address the underlying cause of the disease, the underlying thing that is causing damage to the brain, causing the brain to literally atrophy, to lose millions of nerve cells and especially billions of the connections that those nerve cells make. So doesn't address the underlying cause. It does have side effects, and it's not going to buy you much more than about maybe a half a year. So when you start a patient on Aricept, typically they don't go back to where they were before they had Alzheimer's disease. They go back to where they were cognitively about 6 months earlier. Now that might not sound like much to you, but 6 months of your wife knowing who you are and what your name is can really mean a lot compared to 6 months of your wife not knowing who you are at all. Okay, so it's a really good drug. It's really worth doing. Memantine is a more recent drug. It works on a different chemical messenger molecule system. It's called glutamate, and it has pretty much the same properties. Gives a boost in cognition. The boost does, but after a period, patients start going downhill again, just like all Alzheimer's patients do. So we're taking, absolutely, FDA wouldn't have approved it otherwise, but do understand it's not a cure. It's just a way to treat the cognitive symptoms. So what's on the horizon? One thing is inflammation. As I said, there are about 28 studies that suggest that taken before you develop vulnerability to Alzheimer's disease, this could be protective. But the studies that have been done to treat Alzheimer's disease have been pretty much like this. I did one of them, so I know very well. And the biggest problem is that these drugs that you would use to treat inflammation cause GI side effects and cardiac side effects, as we said. But I discovered this about 20 years ago, I guess. And this is the first picture that was ever taken of inflammation in Alzheimer's disease. I took that in my lab, and nobody believed it for about 3 years. But what you see, those little black squiggles there, those are inflammatory cells that are moving in and attacking. That's what these cells do. They're scavenger cells. They're clustered in particular around a molecule called amyloid beta peptide, which we will discuss in more detail later. But these cells are secreting all kinds of poisons, poisons that are used normally in the inflammatory response to basically kill everything in sight, including bacteria that might be infecting you. So let's talk a little bit about inflammation. If I cut my finger and I get a splinter in there and it gets infected, inflammatory cells and molecules are going to move in, and the way they help you is by destroying everything in sight. They eat the dirt that might have gotten in the cut, they eat the splinter, they eat all the dead and dying cells, and when all that's done, then the inflammatory response starts generating rebuilding signals, and everything clears and you're good as new. Problem is, inflammation works here, doesn't work here very well at all. For one thing, inflammation is almost always accompanied by swelling. You got no place for your brain to go. Your brain is enclosed in a bony box, your skull, and there's no place for it to swell. So if it starts to swell, you're dead. Inflammation is generally a very bad thing to happen to your brain. But it is happening in Alzheimer's disease, and it is causing damage. So can we treat it with drugs like Advil or something even more potent? And the answer is no. It just does not seem to work. I think the main reason is because, one, there's too much damage already done to the brain. This is the classic case of locking the barn door after the horses are gone. And secondly, we can't give high enough doses because we always get side effects. The mainstream of current research is to remove or stop a molecule called amyloid beta peptide. That's the only Greek I'm going to give you tonight. But it is a really important molecule to know about in Alzheimer's disease. It's been around for a long time. In 1906, Alois Alzheimer, who was a German physician, had a patient named Auguste D, last name initial D. I guess they must have had HIPAA regulations even back then. But we only know her as Auguste D, and she was elderly, somewhat elderly. She was demented, and the family gave Alzheimer permission to autopsy her brain after she died. He used a stain that he borrowed from a colleague down the hall, Dr. Bilchowski. He put it on the slide of this lady's brain tissue, and this is what he saw, or something very like it. Here I've taken a section of Alzheimer's brain and stained it exactly the way Alzheimer did. And this is what he saw. All of those black freckle-like things, here's one here, here's one here, here's one here, here's one here. Those are deposits of a molecule called amyloid beta peptide. Now, Alzheimer said, you know, this is probably something significant. He knew that for two reasons. First of all, you see billions of these in the Alzheimer's patient. You see a few in normal elderly people. I mean, it's just night and day qualitatively different. Secondly, it was not only how many you saw, but also where they were. So these amyloid deposits were in the frontal neocortex and the temporal lobes. These are the higher centers of your brain that are involved in memory and judgment. Okay? So makes perfect sense. This is where the pathology is, and that's the kind of disease you get, failures in memory and judgment. If you look at structures like the cerebellum, that's a structure about the size of my fist at the back of your brain, which is involved almost totally in movement. You don't see any of this amyloid pathology. So how much it is and where it is suggested to Alzheimer that this was important. We now know a third thing that has really convinced most people that amyloid is important. You remember I said that mutations in a couple of genes could cause Alzheimer's disease? Guess what those genes are? They're the amyloid gene. They're the gene that codes for the production of amyloid. You get a mutation in the amyloid gene, you get Alzheimer's disease. So that was sort of the clincher to everyone that this stuff is really, really important. So how are we going to deal with that? Millions and millions of these deposits in the brain. Well, our colleagues up the road at Elan Pharmaceuticals had a very, very creative idea. I thought it was wrong, but they had a very creative idea. I give them credit for that. It got a lot of support, and they did it. What they said was, basically, Joe Rogers is all wet. Inflammation isn't bad for the brain. It's a good thing. We can harness inflammation and the immune system to remove this stuff. All we have to do is vaccinate people against their own amyloid. Okay? So everybody knows how vaccination works, like in smallpox. You take some dead smallpox and you scratch it on your skin, and your immune system says, whoa, that's not me. I need to develop some protection against that. And so it makes something called antibodies that recognize smallpox in the future, and anytime you get smallpox in your body, it's attacked right away by these antibodies. So Elan vaccinated people against their own amyloid with the idea that the same thing would happen. The immune system would attack the amyloid and get rid of it. And it works. It absolutely does work. The problem is it kills you. That's just a minor side effect. But yeah, of course you don't want to stir up inflammation in a brain that's already inflamed. And that's exactly what they did. And it killed 11 people before they stopped the trial. They came back and with other forms of immunization against amyloid, weaker forms, those didn't pan out, didn't work. But it is true that when you looked in the dead patients' brains, there was clear evidence that the amyloid had been removed. Clear evidence. Not the best strategy, though, in my opinion. There's still one company, Lilly, that has an approach based on immunization against amyloid, and they have had some success. I wouldn't call it a rousing success. If you check with my financial advisor, he will tell you I have not bought any Eli Lilly stock lately. Nonetheless, they've had some modest successes with this approach, and they are in phase 3 of clinical trials. So I hope it works. I'm not optimistic, but I hope that it works. There are other ways to skin this cat. Instead of removing amyloid after it's there and probably already done damage. The reason you have inflammation in your brain, by the way, is because you have amyloid there. Amyloid, you couldn't make a more inflammogenic substance than amyloid. It has just the protein structure to stimulate inflammation. It's almost impossible to chew up and get rid of, which drives inflammatory cells crazy. So it is a very potent inflammagen, and that's why all the inflammatory cells that I showed you the picture of earlier, that's why they were all clumped around the amyloid. They're chewing on it, they just can't eat it, can't get rid of it. So, but there are other approaches, and we're taking them at SRI. One of the reasons I came to SRI is because it really is different from all the ivory tower places that I've ever been before. In my own institute, which I spent 26 years building, at Harvard and University of Massachusetts Medical School, where I've been, we always thought about discovering new questions, new phenomena, new things that nobody could explain or understand about Alzheimer's disease. What we never thought about was fixing it, how to treat it. That's what makes SRI so different, and that's why I wanted to come here. Because at SRI is, trust me, not an ivory tower. SRI is a place where treatments are developed, where we fix problems. And so I've had an opportunity to work on a new drug for Alzheimer's disease. I've been fortunate to work in particular with Dr. Ling Zhang, who is a brilliant medicinal chemist. A medicinal chemist is, like Ling anyway, is a person who can make molecules of almost any shape or form that you ask her to. She's unbelievably talented. She can make a molecule sit up and bark for you if you wanted. She has come up with a drug that does everything that I wanted it to. It removes amyloid, not by removing it, it keeps it from being formed in the first place. It inhibits the synthesis of amyloid beta peptide. In addition, it is a potent anti-inflammatory, and it works on a different principle from all the other common anti-inflammatories like Advil and Motrin and naproxen that give you stomach and cardiac problems. We don't think that this drug will. I am so high on this drug, I can't tell you. That said, I have to admit, it works like gangbusters in a test tube. Haven't tried it in an animal yet. There are animal models that we have to go through long before we get to people, but I'm really hopeful about this drug. I'm really hopeful that this compound, as I said, it keeps amyloid from ever being made, and it's a potent anti-inflammatory. And I'm really hopeful that this is going to do the job. It's going to get rid of amyloid, it's going to get rid of inflammation, and this will be good for millions of Alzheimer's patients, and it will be good for you and me because we are very vulnerable. Most of all, however, I'm really hopeful that it works because there's one population that is ever more vulnerable than you and I are, than we are. Yes, than you and I are. And that is a group of people who develop Alzheimer's disease with about 67% frequency by the age of 65. 67%. 67%. They have the same pathology as an Alzheimer's patient does by age 35. They are people with Down syndrome. So people with Down syndrome start having amyloid pathology in their childhood. By age 35, their brain looks exactly like an Alzheimer's patient. By age 65, 67% develop frank Alzheimer's disease. Now, what's the problem with Down syndrome? What causes Down syndrome? It's a trisomy of chromosome 21, right? So in Down syndrome, you don't have too few genes or chromosomes, you've got too many. Chromosome 21 has an extra copy. That's why it's called trisomy 21. There's an extra copy of the 21st chromosome, and most of the genes on the 21st chromosome are also repeated by 1/3 too much. And of course, it's like you gave a builder with a plan for a building that had, by mistake, you put in 2 copies of the 10th floor, so you get two 10th floors. And the same thing tends to happen in Down syndrome. You have an extra copy of the genes that code for certain molecules, so you get too many of them. All right? Now, knowing that, what chromosome would you guess that the amyloid gene is located on? Chromosome 21. And not only chromosome 21, but the distal end of chromosome 21, the far end, and that's where most of the problem in Down syndrome comes from. So people with Down syndrome have an extra copy of the amyloid gene, and they make too much amyloid, and it ends up looking just like an Alzheimer's patient. So I'm really, really hopeful, particularly for this class of people, because they are the most vulnerable in the world, that our new SRI drug or somebody else's drug will not only help Alzheimer's patients and you and me, but it will especially help my daughter Dylan. So this is my middle daughter Dylan. She has Down syndrome. I've wanted to do something for her all of my career. I've never had a chance till I came here. I'm really grateful to SRI for giving me that chance. Thanks very much. Questions? Questions? Who wants to know about their aluminum pots and pans? And are they safe? Does everybody hear about the aluminum story? Who knows? Who's heard about aluminum? Okay. So let me tell you about aluminum, because lots of people still haven't gotten that, and it's sort of amusing in a scientific kind of way. Back some time ago, there's a band of primitive Indians in a remote province of Guam called the Chamorros. And the Chamorros, with about half of them by age 50, develop a dementing disorder that looks a lot like Alzheimer's disease. So in their infinite wisdom, about 20 years ago, the National Institutes of Health sent a fleet of really high-blown scientists, including one Nobel laureate, and they went to Guam, and they went out in the province, and they took soil and water samples and brain samples from some of the victims, and came back and analyzed them, and they found that the soil and water had about 5,000 times more aluminum than normal, and the brain samples also had about 5,000 times more aluminum than normal. And so it got out that aluminum was, exposure to aluminum was just going to give you Alzheimer's disease. Okay? That turned out to be all wrong. Okay? First of all, nobody could ever replicate the finding that there was more aluminum in the brain than anybody else. Second of all, how would you like to be a worker for Reynolds in their refinery, their aluminum refinery, if aluminum exposure causes Alzheimer's? Turns out they've done lots of surveys of aluminum workers. They don't have any more incidents of Alzheimer's than any of the rest of us. The real kicker, and this is not widely known, it was a story told to me by Pat McGeer, a close friend and colleague at the University of British Columbia. But the NIH actually sent a team back to Guam to take new soil and water samples, and they got some guides among the Chamorros, which they hadn't done before. And they went and they took soil and water samples where they'd been taken before, and the Chamorros said, "What are you doing here?" And they said, "Well, we're taking soil and water samples from where you live." And they said, "We don't live here. We live 50 miles over there." So the original soil and water samples weren't taken in the right place in the first place, and when those soil samples were analyzed, they had perfectly normal levels of aluminum. So this is a very good thing. Aluminum is one of the most common elements in the Earth's crust. You cannot get away from it if you wear a moon suit. The food that comes from the soil and the water, it's got a lot of aluminum. If you eat too much of the food, you should know that the antacid you take is chock full of aluminum. It is the major ingredient in an antacid. And if that causes you to sweat, you should know that the major ingredient in an underarm antiperspirant is aluminum. So you can't get away from aluminum. Thank God we don't have to.